Now that we've done the factorial ANOVA with two independent factors, it's going to get a little bit more complicated. Now we're going to do a factorial ANOVA with two mixed factors. Now in this ANOVA there are two factors with at least two levels each. One of these factors is independent, while the other factor is dependent. The factorial ANOVA with two mixed factors is kind of like a combination of a one-way ANOVA and a repeated measures ANOVA, because you have the one independent variable and the one dependent variable. So here is my question. Researchers want to see if high school students and college students have different levels of anxiety as they progress through the semester. They measure the anxiety of 12 participants at 3 times, week 1, week 2, and week 3. Participants are either high school students or college students, and anxiety is rated on a scale of 1 to 10, with 10 being high and 1 being low. Use alpha of 0.05 to conduct this analysis. So here is our example. We have an independent variable, which is school, high school and college, and we have a dependent variable, which is week 1, week 2, week 3, because we're measuring the same people 3 times. So that's a dependent variable, while the other one is independent because they're different people. Now, we have the same 7 hypothesis steps as a factorial ANOVA with 2 independent factors. First, we will state our null and alternative hypotheses. So we have 3. We have one for school, where high school will be equal to college, and we're testing to see if they're different. We have one for week, where all 3 weeks are equal, and we're testing to see if they're different. And we have one for interaction, where the interaction is absent, and we're testing to see if an interaction is present. Our alpha is going to be 0.05, because pretty much always is. That's what I said to use, so that's what we're going to use. Next, we calculate the degrees of freedom. Now we're going to have 5 degrees of freedom. We're going to have one for school, one for week, one for the interaction, one for total, and we're going to have 2 of them for 2 different error terms. So notice that we have 2 different error terms here, because we have independent factors and we have dependent factors. Independent factors, like school, have their own error term, and dependent factors, like week, and the interaction, because it contains week, has its own error term. So now we're dealing with 2 error terms instead of just 1. That's because the second error term, remember, is for a dependent variable, so it is going to account for the consistent variability between subjects that isn't accounted for when you have independent factors. So that means we have these 6 degrees of freedom, and we're going to use these equations. You can just study these, they're pretty easy. You just have to know A, B, N. A is 2 because we have 2 A groups, B is 3 because we have 3 weeks, N is 6 because there are 6 participants in each cell. Pretty basic stuff. Everything adds up to 35, so we know that we did it right. Next, our decision rule. Remember that we have 3 hypotheses, so we're going to have 3 decision rules. In order to find these, we're going to use the degrees of freedom for our effect and the degrees of freedom for the error associated with their effect. So you see for school, week, in school, by week, you can see the degrees of freedom that I am associating with each of those. So for school, we're going to be using 1 and 10, and for week and for the interaction, we're going to be using 2 and 20. So we go to our F table, where we have between on the top and within on the side, and first we're going to look up 1 and 20, where we find a critical value of 4.35. So for school, our critical value is 4.35. For week, we're going to look up 2 and 20, and we get a critical value of 3.49. So 3.49 is the critical value for both week and for the interaction of school and week. So our 3 decision rules are, for school, if f is greater than 4.35, we're going to reject the null, and for week and for the interaction, if those f's are greater than 3.49, we're also going to reject the null. Next, we must calculate the test statistic. Now looking at this table, we already have the degrees of freedom. We can just put that in there. We just need to find these 6 sum of squares. We need to find it for school, for the error for school, for week, and the interaction, and the error for that, and for total. So 6 total sum of squares we need to find. And we're going to start with school. We're going to start with A. Now this is just like it is in an independent factors ANOVA. Pretty easy. Remember that we're going to split them up by high school and college because those are our two levels of A. So we need to find the sum of each of those conditions, which we do. We have 93 and 84. And then that's the top part of the first fraction. We take the sums and square them and then add them together. And then the stuff in the equation besides that we already know. We know that b is 3, we know that n is 6, capital N is 36, and t is 177. That's just the total sum. That's everything added together. That's 93 plus 84. So putting all that stuff in there, we find a sum of squares for school of 2.25. That's the first one. Next, we're going to do week, which is the same idea. The A and B are now flipped around, but otherwise it's the same. So we are going to split up the 3 week conditions and find the sums for that. We find 30, 53, and 94. And then that's what's going to go on the top of our equation. 30 squared plus 53 squared plus 94 squared. And then the rest is all pretty much the same as it was for sum of squares school. So now we have our sum of squares week of 175.17. Now we need to find the interaction of school and week. Now this looks kind of bad, but realize that the last 3 fractions, we already found that. We can just put that in there. We're done with that. We just need to find the first part. Now the top of that fraction is asking us to take the sum of every cell, of every A at every B, like A1 at B1, A1 at B2, and so forth. So we find our 6 sums. We have 22, 8, 27, 26, 44, and 50. So that's what goes on top. We're going to square all those things and then add them together, and then divide by n, which is 6. So I'm going to move past this because I've got to keep moving, but if you add all this stuff together, if you do all of this, you find a sum of squares interaction of 17.16. Now we're going to do sum of squares total. We already know the second part, so that's easy. And we just need to find sum of all y squared. So you're going to take each individual score, square it, and then add them together. When I do that, I get 1081. So I put that in the equation, and I find a sum of squares total of 210.75. So those are 4 sum of squares. We just need the sum of squares for the 2 error terms now, and then after that, we're almost done. So let's find sum of squares error for the independent factor, because that's the easier one to do. So we're going to use this equation right here. We already know the second part, remember, so we can put that in there. That's easy. We just need to find the first part. So we're going to find each n at each level of A. Looks kind of confusing, doesn't it? We're going to basically find each subject's sum at each level of A, like I've added to the table up here. So for the first subject at A1, we got 15. For the second subject at A1, we got 16. So we have these 12 values. These 12 sums for each subject at each level of A. So on top, we're going to take every single one of those things, square them, and then divide by B, which in this case is 3. So once you do all that, you multiply, you divide everything, we get a sum of squares error of 1.83. And now we put that in the equation. So now we're just missing one thing. We're missing the other error term sum of squares, but that's easy for us to find. Oops, there we go. We just get 14.34 because we take the total and subtract everything else that we have to find 14.34. We take 210.75 minus sum of squares school, minus sum of squares error for school, minus sum of squares week, minus sum of squares interaction, and all that's left over has to be our sum of squares error for the dependent factor, 14.34. So now we're almost done. We just have to find a few mean squared. Remember that mean squared is just sum of squares divided by degrees of freedom. So like for example, for mean square school, we just take 2.25 divided by 1, and we get 2.25. For error, we just take 1.83 divided by 10 and get 0.18. You just divide across, so once you're that far, it's not that hard to find mean square. And next we just have to find our last f's. These 3 f's, which we find by taking our ms effects and then dividing them by their associated error terms. So we end up with something like this. For school, we divide 2.25, which with its error term, which is 0.18. For week, we take 87.59 and divide by 0.72. And for the interaction, we take 8.58 and divide by 0.72 again. So we get Fs of 12.5, 121.65, and 11.92. And now we can state our results. Based on these Fs, for school, our F was 12.5, so we are able to reject the null. For a week, our F was 121.65, so again, we can reject the null. And for the interaction, again, our F was 11.92. That's greater than 3.49, so we can reject the null. We can reject the null in all three hypotheses. So that means that high school students and college students had significantly different anxiety levels. There was also a significant difference between the three different weeks, and an interaction effect was also present. And that is the factorial ANOVA with two mixed factors.